For this problem, we are required to derive an expression for the value of end deflection for the cantilever beam loaded as shown. Step number 1. Determine the value of wall shear and wall moment. Para sa built-in support sa point O, meron tayong shear sa point O and resisting moment at point O. By taking summation of all forces vertical is equal to 0, shear O minus P is equal to 0, therefore shear O is equal to P. Para naman sa value ng resisting moment, MO, equal yon sa value ng moment na maproproduce ng load P sa point O. Therefore, MO is equal to negative P times A. Step number 2. Sketch the elastic curve of the beam, taking into account the boundary condition. In this problem, the value of deflection and slope at built-in support is equal to 0 and maximum deflection at the pre-end. Usually, sa cantilever beam, yung maximum deflection is at the pre-end. At kapag nag-drawing tayo ng tangent line sa elastic curve at point O, horizontal yung maproproduce natin na tangent line at point O. Therefore, the value of slope at point O is equal to 0. Step number 3. Use the method of sections to determine the bending moment M at an arbitrary distance x from the origin. Sa cantilever beam, may mga pagkakataon na kung saan mas napapadali yung solution depende kung sa built-in support or sa pre-end tayo nag-start ng ating x. Pero kahit saan ka mag-start ng x mo, kung sa built-in support or sa pre-end, same pa rin yung magiging answer mo. So, mag-take tayo ng moment sa distance x. Moment is equal to EIY double prime. Yung MO muna, equal siya sa negative PA, plus BO, equal yan sa P. Yung moment arm niyan hanggang distance x is x. Minus yung load P, at ang moment arm niyan hanggang sa distance x is equal to x minus A. Step number 4. By integration, integrate the expression for M twice to obtain the value of EIY. Kapag inintegrate natin yung EIY double prime, equal yan sa EIY prime is equal to negative PA times x plus P x squared over 2 minus P times x minus A squared over 2. Do not forget the constant of integration. Para sa EIY prime, ang gamitin natin ay C1. At kapag inintegrate natin ulit yung EIY prime, equal na yon sa EIY. Yung constant is negative PA at ang integration ng x is equal to x squared over 2 plus P over 2, kapag in-integrate natin yung x squared, equal yan sa x cubed over 3. Labas natin yung constant, P over 2, at ang integration ng x minus a squared is equal to x minus a cubed over 3, plus integrate natin C1, equal yan sa C1x, at ang constant para sa equation na to ay C2. Sinimplify ko lang yung equation ko for EIY. Step number 5. Evaluate the constants of integration from boundary conditions. Since sa support tayo nag-start ng x or yun yung ating origin, when x is equal to 0, walang movement sa support, kaya walang deflection, kaya yung value ng y ay 0. At again, tulad ng sinabi ko kanina, yung value ng slope sa point O or sa support is 0. And when the value of x is equal to L, yung value ng y natin is maximum. Ito na ngayon yung gagamitin natin na boundary condition para makuha yung value ng C1 and C2. Yung unang boundary condition na gagamitin ko is when the value of x is equal to 0, the value of deflection is equal to 0. Using the deflection equation, y is equal to 0, x is 0, x is 0, x is 0, therefore yung magiging value nito is negative a cubed. Nalimutan ko sabihin sa naunang video na in-upload ko, terms with negative values in the parentheses are negligible. So, hindi din natin isasama yung term na to. X is 0, therefore the value of C2 is 0. Yung next naman na boundary condition is when the value of x is 0, the value of slope or y prime is equal to 0. Using the slope equation, y prime is 0, x is 0, x is 0, x is 0, kaso negative yung term na to, kaya not included. Therefore, C1 is equal to 0. Ang pinapahanap sa atin sa problem na to is yung value ng end deflection. Therefore, when the value of x is equal to L, equal yon sa y at n, or equal din yon sa y max. Using the deflection equation, makukuha na natin yung value ng yn. EI y max, negative PA, the value of x is equal to L squared over 2, plus Px is equal to L cubed over 6, minus P over 6, L minus A cubed. C1 and C2 is 0. So, ito lang yung ating equation. Isi-simplify lang natin to para makuha yung value ng y max. Using algebra, simplify lang natin PAL squared over 2 plus P over 6 L cubed minus P over 6. I-expand natin yung L minus A cubed. L cubed minus 3L squared A plus 3LA squared minus A cubed. I-distribute lang natin yung P over 6 sa lahat ng term. Minus P over 6L cubed. Magiging positive to. P over 2 kasi 3, 6. L squared A. Magiging negative. P over 2 ulit. LA squared. This time magiging positive. PA cubed over 6. Kung mapapansin natin yung ating equation, ito ay positive, ito ay negative, so makakancel kasi 0 yon. Ito naman, at ito, negative at positive, so pag pinag-plus natin, equal to 0. So, ang matitira na lang sa equation natin ay ito. Nire-write ko lang yung term na natira sa equation. Kapag sinimplify natin to, yung common denominator nila ay 6. Ito ay magiging negative 3 PLA squared plus PA cubed. Gawin natin na common factor yung negative PA squared over 6. So, ang matitira sa first term is 3L. Sa pangalawa naman ay negative A. Ito ngayon yung ating EI y max. I-rewrite lang natin, y max is equal to PA squared over 6EI 3L minus A. Para mawala yung negative sign, ilagay natin na downward or pwede din naman na arrow sign lang.